Hello everyone, welcome back to Code Studio, and in this video we will be discussing a question that appeared in the recent Codeforces Round 642 Div.3. The question that I am discussing in this video is that B question that I am highlighting, two arrays and swaps. Just get a glimpse on this question, two arrays and swaps, and try to find out the algorithm used to solve the problem. These are the test cases given to us with the problem. So what the problem actually means is that you would be given two arrays, namely A and B. The length of array A and B are same and also given to you as n. After you have the arrays, you get a definite number or k that actually gives you k number of moves. Actually maximum moves you can perform the array. What are the moves? So a move in this case of this problem is to swap two numbers of this array in this manner or even something like this. We also do have an implication that we have to perform the moves such that the sum of each number in the array is as maximum as possible. How to go up on this problem? So the base idea is you have to make moves in a manner such that the small numbers are thrown away into B and the large numbers are brought back into array A. In this case, we have thrown away the small numbers which we are representing with the mouse, and we are bringing the large numbers into array A representing the grizzly bears. This works fine always, and this is the working principle behind solving a problem. But since we shouldn't be always comparing each and every element every time with the other element of the whole array and doing mundane tasks, we should optimize our method. Let me actually show you a new way of looking at this problem, and let's optimize our problem. First, we were given an array like this. So let's sort our arrays in ascending orders. After sorting both our arrays, we compare elements in this manner because the arrays are sorted and comparing the smallest of array A to the largest of array B. We then swap the digits if element in A, that corresponding elements we are comparing in A is smaller as compared to the element in B, that corresponding element in B, we swap the elements. Also, we have some available number of moves, that is k, because we have restriction on the moves, right? So we should also make that k in mind while solving or while swapping. After completing all the moves we have, or after completing all the possible swaps we can make, we then calculate the sum of elements in modified array A and then provide the answer to the output. Let us see the devised algorithm in a glimpse and then apply that algorithm to the examples given in the question. Step number 1 would be sorting the arrays. Step number 2 would be comparing the extreme elements and comparing in that manner as we have seen earlier in the slide. Step number 3 would be swapping the numbers such that we throw away the smaller numbers into the B array and bring the larger numbers into the A array. Step number 4, once the moves are completed or once we have completed comparing all the elements, we calculate the sum of elements in array A and then provide the answer. Now, let us apply the devised algorithm on the test cases given in the question. Not exactly all test cases, let's just see the first three test cases. So the first test case gives us two arrays A and B as follows, and n is 2, k is 1. So we have only one move we have to make such that the sum of elements in array A is as maximum as possible. So step number 1 would be sorting the arrays. We have the arrays are given already sorted. So we'll compare the elements in such that manner, and since our moves are only one, so we'll then swap the first element in array A to the last element in array B and then compute the sum to be 6. This is how we provide the output to the program. Test case number 2. We were given 5 numbered arrays. The first would be 5, 5, 6, 6, 6, 5. The second would be 1, 2, 5, 4, 3. We are given 5 moves we can make to make the sum of array A as maximum as possible. So let's just sort the arrays first. After sorting the arrays, let's start comparing. Since the first element 5 is equal to the last element 5, there is no point in actually swapping the elements. The second 5 and the last but one in B 4, there's nothing to compare because 5 is greater than 4. In that manner, there is no way we can swap two elements or change anything. So the given array has the maximum sum. So we print out the output, the maximum sum, to be 27. Test case number 3. We are given the first array to be 1, 2, 3, 4, 5, already sorted. Array B to be 10, 9, 10, 10 and 9. So let's first sort them. Fine, sorted. And we are given 3 moves that we can make to make the array A as maximum as possible. So here is the actual or more proper way where we can actually swap and make the array A to be as large as possible. So let's start comparing 1 and 10. So swap 1 and 10, swap 2 and 10, swap 3 and 10. Done. After swapping, the maximum sum would be 39 because we have swapped the first 3 of array A to the last 3 of array B. This is how we go upon applying our algorithm to different problems. So let's just code the algorithm we have finalized in our code editors. I have created a file named 2arraysAndSwaps.cpp and let me write down the code here. So let me just include the basic skeleton that we do in every code. On the first node, you would be given some number of test cases. So first declare a t that takes in the number of test cases and then start a while loop in this manner that runs on all test cases. So for a given test case, we are given two integers n and k. That actually means n and k. The n means the maximum number of the given array A and B, and k is the number of moves you would be having. After inputting n and k, we have to declare two arrays, A that is having a maximum of n and B that is also having a maximum of n. Let's also input integers into array A and array B respectively. So for so I'll input array I. So I'll input integers into array I and then do the same for array B. So this is how you input the elements. After inputting the elements, the step number 1 we have to follow would be sorting the arrays. So in this case, you can actually write down a big chunk of code to sort the arrays, but since we are doing competitive coding and we have to be fast in submitting our problems, we will use a standard algorithm that is already declared in an algorithm header file and then use that header file that would be of this form sort. Since the array would be A, actually you have to write down the starting address and the ending address of the array. So the starting address would be A and the ending address would be A plus n because there are n elements, right? So we have to also sort the second array B and B plus n. So step number 1 is done, that is sorting the arrays. After sorting the arrays, we have to run a loop that actually checks the extreme elements and we have to move on like in that manner, right, that we have already discussed. So let me start a loop that actually takes care of managing the k variable, that is k greater than 0. I'll actually decrement the k variable whenever I swap two numbers. Okay, so if a of I is less than b of n minus I minus 1. That would be the last button. Let's take an example of I equal to 0. So when I equal to 0, then a of 0 would be less than b of n minus 1. That actually what we have already discussed, the extreme elements, right? So I should also declare an initialize I variable, I equal to 0, that actually increments on every time I run a loop. So after here, I increment the I variable, and here a of I, when this is happening, I would be swapping those two numbers. So swap. This is also a standard algorithm that is already included in hash include algorithm header file. See, we shouldn't actually hard code everything during competitive coding. Time is the most important feature in competitive coding, so you have to utilize all other libraries or all other functions that are actually available and focus more on problem solving or finding the logic behind the given question, because implementing anything is quite simple with the algorithms that are predefined, that you just have to know and you'll know through practice. So just use them as a need. I already discussed when I will swap the numbers, I would decrement the k variable. So this is how you run a loop. But there's also another implication that if there is nothing to be swapped, then I would go on incrementing the I loop, and k would always be greater than 0, of course, because there is no need of swapping, and my code would dump sometime with a segmentation fault, because I'll run this into an infinite loop for some given test case, right? So I should also include a case when I is less than n, because when I is less than n, that means we are inside the array, and when I go out of the array, then the loop breaks, obviously. So I wouldn't end up in an infinite loop, and my program wouldn't give any segmentation fault. I find we are up now. Oh wait, I have to print out the answer, right? So for printing the answer, I have to calculate the maximum sum, that is the sum we have found out until now. So I will run a loop across the variable, across the array A. So sum equal to sum plus each element in array A. I'll also declare a sum variable that is equal to 0, and after calculating the sum, let me print out the sum, and we are done. So let me try compiling and submitting the problem. Okay, let me copy the test cases in the question. So I'll copy this, then move to terminal, and then print. My answer is 6, 27, 39, 11, and 17. Okay, we are fine. Let's then submit our problem and wait for the verdict. So my code is running. Yeah, my code got accepted. Fine. We went very well with this question. I have explained the basic logic, and then we optimized our method so as to not fall in some highly time limit exceeded case, or memory limit exceeded, such case of failure in test cases. And I've also discussed how to utilize the algorithm header file by utilizing the sort function and also swap function. So good to go. So bye for now. See you later. Stay home, stay safe. Signing off, Sai Ankit, Code Studio.